Chapter 10, Sequencing Series. We're actually going to skip 10.1 because it's pointless, to be honest. And we're going to start with 10.2, an arithmetic sequencing series. So first, let's talk about what a sequence is. A sequence is just a list of numbers that follow a certain pattern. So something like 2, 6, 10, 14. That's a sequence. You just, if you're noticing, you're adding 4 every single time. That's actually called an arithmetic sequence, which we'll talk about in a bit. But there's lots of types of sequences. 2, 2, 2, 2. Right? The pattern is just copy it all down. You could multiply by a number. I could do like 5, 25, and then 125. That's a sequence. I can use something. You can even have a sequence like this: 1, 4, 9, 16, yada yada. Right? We're just squaring every number. Those are sequences. What we're gonna do in this lesson is talk about specifically an arithmetic sequence. So an arithmetic sequence is one that's based off adding and subtracting. So like the first sequence we talked about where we just added 4 every single time: 6, 10, 14, 18, 22. Or you can even subtract every single time. So I have a sequence that's like 23, 20, 17, blah 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 blah. You subtract it every single time. That's an arithmetic sequence. So we say arithmetic. Arithmetic is when you're actually doing the work. When it's a noun, when you actually do it. When it's a verb, when you're actually doing math, it's arithmetic. When you're labeling it, it's a noun, it's arithmetic. So an arithmetic sequence. So first things first. How do we find a formula for this thing? That's what we want to find. So for an arithmetic sequence, to find a general formula for this. So if I just I want to figure out what the 10th term is, I want to plug a number in and figure out the 10th term. We use this formula right here. And as always, I will give you that formula. You just gotta know how to use it. Well, first up, what is A1? That's the first term of the sequence. So like right here, A6 would be my A1. It's my first term. Over here, 23 would be my A1. Let's talk about what D is. D is known as the common difference. So it's what you add every single time. So 6 to 10, 10 to 14, we're adding 4 every single time. This makes our common difference 4. Over here, right, you're subtracting 3 every single time. Minus 3, minus 3. My common difference over here would be negative 3. So it could be positive or negative. So that's the first term. That's the common difference. Those are probably the two most important ones. What is N? N's a term number we're looking for. So that's term number. So we'll talk about that more, but that's the number you're looking for. So this right here, this is A1. So my N would be 1. It's the first term. This is A2. My N would be 2. A3, A4, A5. So whatever number actually, what term number it is, that's what N is. And this right here, AN, is the actual term. So what does that mean? Right here, this is A4 is 14. Right, so A4 is 18. This would be 18. Right, the fourth term is 18. So that's the formula. So let's first try to. First thing to do is let's make a formula using the indicated information. So AN equals A1 plus N minus 1 times the common difference, right? That's the formula from right there. And again, we have a lot of stuff. We have A1, negative 4. We have our common difference. I'll hold N off for now. So that's a basic formula. I can do a little math to make this prettier. Negative 4 plus 6n minus 6. So AN equals negative 4, negative 6 is 6n minus 10. Right, that's a general formula. Add the two numbers together, 6n. So that's my formula. And if I want the 9th term here, I just plug in 9. So A9, that says A9, is 6 times 9 minus 10. Also known as 54 minus 10, or 34. So again, when n equals 9, the ninth term, when I plug it all in, I get 34. A9 equals 34. So the ninth term of the sequence is 34. Let's do it again right here. Again, we have our formula. And then we have everything we need. We have A1 is 15. The common difference is -8. And I get AN equals 15 plus n minus 1 times -8. Let's distribute now. This is -8, so we're going to multiply it out. Right? -8 times n is -n. And -1 times negative is +8. Add up to like terms, and I get -8n minus 23. That's the general formula. And then now I want the 20th term. So the way this works is A20, you just plug in 20 for n. So -160 minus 23, -183. So the 20th term is -183. Right, that's all it is. Oh, you have this formula, plug A1 and D into your formula, find this, and then you can find any term you want. Now let's go a little bit tougher. This is the same thing. I'm going to skip this one. Same thing over and over again. Let's solve this one. It's a little more fun. So again, find the indicator term for the arithmetic sequence. So they want me to find A18. So first, right, my general formula is this. Again, I will give you that formula. Just gonna know how to use it, right? So this is my general formula. AM term equals the first term plus n minus 1 times the common difference. Now this time they actually tell me, like over here they told you what A1 and D were. Over here they don't. You gotta find it yourself. Luckily it's not too bad, right? First term is right here. Hey, there you go. And the common difference, as long as you do basic math, you could get this. Right? 12 to 25 is 13. So that's common difference. Right? And now we could plug it in, make an actual nice formula. 12 plus n minus 1 times 13. Distribute. 12 plus 13n minus 13. Add like terms. an equals 13n minus 1. And now, all they want is the 18th term. So plug in 18. The 18th term is 13 times 18 minus 1, which is 13 times 18. That is 234 minus 1, 233. So 18th term of this sequence happens to be 233. Right? So you got 12, 25, 38, 51, and then blah, 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 233. Right? If you keep on adding 13 over and over and over again, you eventually get there. So that's the process. So now let's go a little backwards. Now all they want us to do is write the equation for the nth term. Right, the equation for the nth term is something we've been finding already. It's this thing. That's the equation for the nth term, because if you want to find any term you want, just plug it in. Right? If you want the 20th term, plug in 20. If you want the 10th term, plug in 10. So super powerful. We want to find the equation for the nth term. Again, so that formula is just the thing we've been using so far. It's this. Now sometimes it's really easy, like this one, where we have, right, we're looking for an equals a1 plus n minus 1 times the common difference. A1, 12. Common difference, 12 minus 12 to 3, 3 to -6, is -9, right? You're subtracting 9 every single time. By the way, I never mentioned this, because it's usually common sense, but the way you find the common difference is a2 minus a1. Second term minus the first term. So here you'd get 3 minus 12 is -9. Right? Again, most of the time we don't use it, you just kind of look at it and go, okay, it's that or that. But that's a kind of a proper way of doing it. So I have my a1, I have my common difference, plug it in. It's all you need. Right? If you want to make a formula, all you need is a1 and the common difference, and you can make a formula. So 12 plus n minus 1 times -9. Distribute 12 plus -n plus 9, right? Two negatives make a positive. Add up like terms, and my formula is negative 9n plus 21. Right? Remember, once you have the formula, you can do anything you want. You want to figure out the 12th term, plug in 12. Want to figure out what term equals 13, plug in 13, solve for n. So that's the idea. That's the easy one. How about a harder one? Like this. Now remember, this is my formula. Notice what's missing? A1. So here's a hint. Anytime you're missing A1 or common difference D, plug it into the original, plug into the basic formula, AN formula. So let me show you what I'm talking about here. First, let me erase this because I need a little space. So let's erase. Look at that. Movie magic. So I'm going to need a little space here. So what I mean by that is, like, let's plug what we have into this formula here. So here's my formula. And I'm going to plug what I have in. So my common difference is 8. This is going to be 8. A6 equals 12. So what does this mean? Well, when I plug in 6, it equals 12. That's what all that means. When you plug in 6 for n, you equal 12. So it's going to be like this. Right? Again, right? When you plug in 6, it equals 12. And my common difference is 8. And look at here. Only thing you're missing is A1. So let's do some math. Do this first over operations. And I get 12 equals A1 plus 40. Subtract 40 from both sides. A1 equals negative 28. So now I have my A1. Now I could make a formula, right? Because all you need for the formula is A1 and the common difference D. You didn't have A1, you had to find it. So how do you find something when you're missing it? You go back to the original formula. And now you can now you can come up with a generic formula. Right? So again, all we need is A1 and the common difference. And my A1 is right here, negative 28. And my common difference they gave me already is 8. So I have this. So that's your general formula. If you want, you can simplify it. Negative 28 plus 8n minus 8. Add like terms. an equals 8n minus 36. And that's how I do it. So again, if you want to make a general formula, all you need is A1 and the common difference, right? The only two things you want to fill in are A1 and the common difference. Sometimes it's super easy like this. Even this one. I'm going to skip this one, right? If I want to do this one, A1 is 13, plug it in. Common difference is 6, plug it in. Easy. When it gets harder, when you're missing either A1 or the common difference, you always got to go back to the original formula. Go back to the AN formula and plug it in. Plug in what you have to find the missing things. We're going to do another one of that right now. So let's look at this one right here. Right? Same idea, just want to do it over again. So they want me to count the general term of the sequence. That's what this means. Find the equation of the nth term. And they give me this. If you notice, again, we're missing A1. So first, let's find A1. So the way you find it is you go back to your original equation. Anytime you're missing anything, go back to the original equation. And now let's plug in what we have. We do have a common difference. D is negative 4. So right here, let's make that negative 4. And again, what does this mean? This is the most important part. What does that mean? This means when I plug in 5, it equals negative 12. When I plug in 5, I get negative 12, right? The 5th term is negative 12. So we have this. We can simplify this a little bit. That's my ugly 4. Slightly uglier 4. So now we have this. We get A1. Now negative 4 times ugly 4 is negative 16. Plus negative 16. I don't know why I put plus there. Right, get A1 by itself. Plus 16. Plus 16. A1 equals 4. Right, so now I have my A1. I have my common difference. If I want the general formula, that's the only two things you need. Right, all you need to fill out is A1 and the common difference. The common difference is negative 4. A1 is 4. plug it in. You could simplify this. Now, honestly, you could leave it like this. That is fine. That is an equation. I would give you full credit, but we're not lazy. Distribute this. 4 plus negative 4n plus 4, right? Negative times negative is positive. And then simplify it a little bit, add like terms. Negative 4n plus 8. And there's my ugly box. But that's the idea, right? If I want you to find general term sequence, the only things you need to do are A1 and you need to plug in an A1 and the common difference. Right? If you're haven't been missing any one of those two, find it. Easiest way to find it is go back to the original formula. Okay, we're going to skip arithmetic mean because honestly it's a big of a deal. You just add them up and divide by 2. And we're going to go to series. So we haven't talked about what series is yet. So series, like it says right here, is formed when you add the terms of a sequence. So if you have a sequence 2, 3, 4, adding 1 every single time, blah, blah, blah. You want to make that a series, just adding them up. 2 plus 3 plus 4 plus 5. Yada, yada. Right? So that's a series. It's when you add them up. So with this stuff, we're going to care about, like, what's the sum of what is, let's say, S1, sum series. That means, what's the sum of the first one? Well, in this case, just 2. S2 means, what's the sum of the first 2? 5. S3, what's the sum of the first 3? 5 plus 4, 9. And so on. Now again, we can keep on doing this, or just like we do with sequence and series, we could use the formulas. I would always give these to you, remember? This again, I would always give you the formulas. It's clear you know how to use it, not that you memorize it. So here's 2 formulas. Here's a general one, which I don't like. I usually like the 2 outside, so we're going to use this instead. N over 2, A1 plus AN. Right, same formula, smooth the 2 on the outside. This is one I'm going to give you, because the one you see a lot more. I'm actually not the biggest fan of this sequence because people have an easy time with A1. N's easy. AN, a lot of people mess up easily. They oversimplify it. So we will use it. I'll talk about it, but not the biggest fan. The one I actually like is the longer one. This one right here. Why am I a fan of this one? Well, it has stuff we know how to use. A1, I know how to get that. N, like always. And the common difference D. Right, so that's why I like to use that one. And it's a little bit longer, but it's stuff I'm comfortable using. So that's the general idea. So let's do some examples. So look at this first one. They want me to find the sum of this arithmetic sequence. So it goes 2, 4, 6, blah, 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 100. So first let's see what we have, right? So to use these formulas. So I have A1. I actually have the common difference. I know every single time we're adding 2. And I have the last term of sequence. This is actually known as AN. Now there's, see, look, this will be good. I have AN, I have A1, I have A1, I have a common difference D. I think if you notice, we don't have N. The difference between AN and N. N says how many terms of sequence are there. Like here we have, this is the first term, second term, third term, blah, blah, blah. What term is this? So I don't have N. AN is like the actual number. Like what's the 10th term? 100 or 200, whatever. So if you remember what I said earlier, anytime you're missing a term, go back to the original. Go back to the OG equation. So we're going to go back to the first equation we do. We use AN equals A1 plus N minus 1 times common difference D. Like we talked about before, I have things. I have A1, 2. I have the common difference, also 2. And then right here, AN, that's 100. Look at the only thing I'm missing, N. So then we're going to use a lot. Anytime you're missing a certain term, always go back to the original one. Always. Go back to the original formula. So here I have 100 plus 2 plus N minus 1 times the common difference 2. Lots of ways you can do this. You can distribute the 2, add them up. I'm just going to do this. I'm going to subtract 2, get 98 equals N minus 1 times 2. I'm going to divide by 2 here. 49 equals N minus 1. Add 1. N equals 50. Right, so to have my N. Now I can plug into any formula I want. I'm actually going to use the easier one this time because you actually have a last term. Only time this one's easier if you actually have the last term. And this time I do. It's 100. So the way I'm going to use this formula is like this. So Sn, that means sum. S stands for sum. The first 100 term is N2, A1 plus AN. N, we just figured out it's 50. A1, I know is 2. And AN is not 50. A lot of people put 50 there. It's the number, the value, 100. So I'm going to get 50 over 2 is 25 times 102. And then the sum of the first 50 terms is 25 times 102, which is 2550, I believe. But that's the idea. As always, you have formulas you can use. If you're anytime you're missing one of the terms of these formulas, go back to the original equation. Okay, let's look at 4b. Same type of concept. You have, this time we have n. N equals 16. AN equals 240. D equals 8. Look at my equations. There's something I'm missing again. I have n. I have AN, which I'm going to need for this one. And I have common difference 8. I don't have A1. I need A1 in either formula. So I need to find A1. And the same thing we always do. If you're missing a term, go back to the original. That's my original equation. Plug in what you have. Common difference is 8. N is 16. And this is AN is 240. So I get 240 equals A1 plus 15 times 8. Let's see. It's 80 plus 40, so 120 equals A1, 240. A1 equals 120. Right? Again, once you have that, you can plug into any formula you want. Again, we have the last term, so I'd be remiss if I didn't use the easier formula. S of 16, because we have the 16th term. Just using the same formula I used right here. Would be n over 2. In this case, my n is 16, so 16 over 2. The first term, in this case, is we just found is 120, plus the last term was 240. So I'm going to get 8 times 360. Whatever, that's a 0, 48, 24, so 2880. Alright, again, same idea. Let's do one more of these, then we'll move on to something a little different. The sum of the first 50 natural numbers. So first, let's think about what those are. Let's write them out. First 50 natural numbers are 1, 2, 3, 4, dot, 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 50. Now again, let's see what I have. I have A1. I have the common difference. We're adding 1 every single time. A1 is 1. Common difference is also 1. And I actually have what n is, because natural numbers. I know n is going to be 50. I want the first 50 natural numbers. It says so right there. And AN is 50. My last term is also 50. So you could plug it into the formula. Sn equals n over 2 times A1 plus AN. This is a rare case where n and an are actually the same, because I want the first 50 natural numbers, which is n. And then the 50th natural number is also 50. A1 is 1. So you can get this, 25 times 51, whatever that turns out to be. So that's how you do that. Now let's go a little backwards. So by backwards, I mean we're going to use a sum formula to come back to find the first term, or in this case, the first 3 terms. So again, talk about, look what they give you. Sn, n, and an. The only formula that has all 3 of those is the one I'm actually not a fan of, I used a lot, is this one. Right, so the only formula that has all 3 of those is Sn equals n over 2, A1 plus AN. Let's plug in what we have. This is 120, n is 8, and AN is 36. So look at, if I do that, I can find out what A1 is. 120 equals 4 times A1 times 36. Divide by 4 is probably the easiest thing to do. And I get 30. Oh, divide by 4 and that's 40. Duh. 30 equals a1 plus 36 minus 36. a1 equals negative 6. So that's my first term. Now I want the first three terms. So I have my first term. That's about it. I don't know what the next term is. I'm not sure what the common difference is, but I could find it. Remember, anytime you're missing something, go back to the original equation. So I have this. I know what the first term is now, negative 6. I know when I plug in 8, I get 120. Sorry, wrong. When I plug in 8, I get, that's a sum. It's not a sum equation. It's a term equation. I get 36. That was embarrassing. A minus 1 is 7 times the common difference. Then here we solve it. 42 equals 7d. Divide by 7. D equals 6. Now let's talk about how to find the next couple of terms. It's really easy. I don't think I talked about this yet. Well, if you know the first term is negative 6, the next term, well, if the common difference is 6, you just add 6 to it. Negative 6 plus 6 is going to be 0. Just keep on adding 6 to it, the common difference. I get 6. I can keep on going if they want me to. I get 12, 18, I can do this all day. 24, 30, 36, easy. I'll calm down now. But those are the first 6 terms. 3 terms. Same thing over here. Right, exact same question. Look what happens. They give you the first term. They give you an, they give you sn. What's missing? N. Now, unlike before where I plugged it into the original equation, they gave me the sum equation, so I'm going to plug it into the same sum equation they have here, because they love that equation. I don't like it. So I'm going to use the exact same equation. Plug in your stuff. I don't have n, so whatever. Be like that n. But everything else I can plug in, right? I have a1, I have an. Right, now it's just math. Add those two up, I get 264. Now, n over 2 times 264, I can reduce these actually and get 132. So I get 5280 equals 132n. About 132. I believe you get 5 or 15. Let me use the calculator because I'm making a joke of myself right now. So let's see, and I get 5280 divided by 132. 40. This is before. I have my n, I have my a1. I still need a common difference. So how would I do it? I would go back to the original equation. Plug all that in and find my common difference. My a1 is negative 24. My n is 40. When I plug in 40, I get 288. Find the common difference and you can keep on adding it to do like we did there. So that's that. That's using the SN formula to go backwards. Now let's talk about something new. Sigma notation. So look at this. Right, it looks really scary. It's this notation. So a couple things. Sigma is this Greek symbol right there, but it stands for sum. That's all it is. If you see the E sign, that doesn't mean sum, it means add up. That's all this is. This is a sum notation. That means to add. Now the way this works is this. We're going to start down here. So we're going to plug in 1. So 3 times 1 plus 9. And then we're going to keep on counting up. We're going to plug in 2. 3 times 2 plus 9. And then we're going to plug in 3. 3 times 3 plus 9. And we're going to keep on going. Up until you get to the top number. Then you're going to stop. It's my weekly time at the stop sign. So you keep on plugging numbers in. 1, 2, 3, 10, blah, 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 10, 11, 12. So you get that. Once you do all that, once I go, okay, 3 times 1 plus 5, that's 12. 6 plus 9 is 15. This is 18. Blah, blah, blah. 36 plus 9 is 45. Right? Once you get all those numbers, what do? Well, you do the E thing, which means add them all up. I know that looks like a lot of work, and if it is, if you did it by hand, it would be. But we have a formula for this. We're finding the sum. We have a sum formula. We have 2 of them, actually. N over 2, A1 plus AN. Or the one I like but I haven't used at all yet, 2A1 times N minus 1 times D. Right? So either one works. But again, I could use this one because it's a little easier in this case, right? What's my N? I have 12 terms. What's my first term? 12. What's my AN term? What's my last term? 45. So I get 6, 12 over 2, plus 57, also known as, let's see, 2, 4, 3, 42. Right? So I don't need to count it one by one. I can just use that. Or, some of you guys like, yes, you guys should use your calculator. Now, it's not, you should know how to do it by hand also, but on your calculator, if it's updated, you just put math. If you look toward the bottom, there should be a summation one. See a little E there? And what you do is just plug it in the way you see it. Now, we don't have a K, but just put X equals 1. Top is 12. And then one right here is 3X. Because again, we don't use K, we just always use X plus 9. And you get your answer, 342. Right, so that's how you do it in the calculator. This is how you do it by hand. You're not going to add them all up by hand. What you can do is use a summation formula. Same thing here. What's the one difference with this one is you're starting at 4. So it'll be 4 times 4 plus 1 plus plug in 5. 4 times 5 plus 1 plus plug in 6. All the way to you get to 13. Okay, let's finish off with some application problems real quick. So this is the first one. There are 25 seats in the front row of a theater. Each successive row contains 2 more seats than the previous row. If there are 24 rows, how many seats are in the last row of the theater? So here's the key thing, a couple things. So if 24 seats in the first row, there's my A1. Each row contains 2 more seats, so that's my common difference. You're going plus 2 each row. If there are 24 rows, so that's how many terms I have. That's like my N is 24. How many seats are in the last row? So the very key thing here is are you asking me a sum formula or a term formula? It didn't say total anywhere. So I'm actually not going to do a sum. I'm going to do a general AN formula. If it said total, I'll do a sum one, but all it's asking for is how many in the last row. So I'm doing this. And you already need. A1 is 28. Common difference is positive 2. N is 24. There's 24 rows. Plug it all in. And you get the number of rows in the number of seats in 24th row are 28 plus 23 times 2. So that's 46 plus 28. So 74. There's 74 seats in the last row. Next one. Jose averaged 123 total pins in his bowling league this season. He is taking bowling lessons and hopes to bring his average up by 8 pins each new season. Write an equation to represent the F term of sequence. So let's see what's going on. He starts off with 123 total pins. That's A1. He hopes to go up by 8 pins. So my common difference is going to be 8. Do you want an equation? Remember, the way you write an equation, all you need is 2 things. Funny enough, the same 2 things I got. A1 and the common difference. So this is 123. That should be A1, not AN. I'm not a fool. That should be an 8. So my general form is going to be this. 123 plus N minus 1 times 8. Distribute. Don't forget that you get 8 by both of them. Add like terms. And you get 8N plus 115. So that's my general formula. And if the pattern continues, during what season will Jose average 87 points per game? Ah, we haven't talked about something like this yet. Notice what that is? That's not saying how much is he scoring on the 10th game. It's saying, hey, his score is 187. This is AN. I'm looking for N. So I'm plugging 187 into this part. Right, subtract 115. I get 72 equals 8N. Divide by 8. It looks like it's going to be 9 years until he gets to an average of 187 per game. Slow and steady. Slow and steady, Jose. You get there. Slow and steady. Torso in the race, not the hair. C. Is this a reasonable pattern to continue indefinitely? Explain. Remember, we always have trouble when it says indefinitely. That's not going to happen, right? I think the max, the best point you could score, the max, is 300, right? It's like a perfect game. So if you keep on going up, definitely you're gonna get past 300. So no. Scores cannot pass 300. Certain number. So that's it for that one. Last one real quick. When an object is in free fall and every resistance is ignored, of course, make it easy on ourselves, it falls 16 feet in the first second. So A1 is 16. Falls 80 seconds during the third second. Oh, during 48 feet in this next second. Whew, skip that. 48 feet in the second 2. And then 80 feet in second 3. How many total feet object fall in the first 10 seconds? So they want S10. That's what it's looking for. Now again, this is one where you can use my favorite formula, right? So S10, there's two formulas for it. N over 2, A1 plus AN, or my baby, 2A1 plus N minus 1 times D. Right? Now you have two formulas here. Look what you have though. I have A1 is 16, A2 is 48, A3 is 80. I don't have AN. So if you want, you could find it. Definitely could find it. I have N, and it's 10. I could find it using my basic formula. Right? Plug in A1, which we know. Plug in the common difference, what we know. Plug in N, what we know. And you can easily find AN. But instead of do that, I'm going to use my favorite formula because I haven't been able to use it yet, and I'm itching to. So this is the formula I like to use. Because it has it all kind of baked in there. I don't need to find AN. All this stuff's going to take care of it for me. N is 10, right? 10 seconds. A1 is 16. N is 10 again. And the common difference D, if you do 48 minus 16 or 80 minus 42, you get the same thing. You get 32. Yeah. So, 97.5. 5. 2 times 16 is 32. Plus 9 times 32. Very important thing here, guys. You can't get lazy inside here. Order of operations, this goes first. Because you're multiplying. I see so many people add 32 and 9 first. And it hurts me. So this goes first. And really quickly, this will be 288 plus 32. So it'll be 5 times 320. Which equals 0, 0, 16. So 1600. And that's it.